So our example from Monday was the different students' birthdays in different groups. And each group, if each group had one guess on what they thought the class average would be, that group would guess that group's what? So like we started with this. What did each one of those dots represent? That group's what? That was that group's mean, that group's average. So if they had one guess on what they thought the population parameter was, it would be whatever their group average was. Then from there, we found 68%, 95%. And so we made these dots outside like this on each one. And so basically at that point, which we haven't really talked about what it is or why, but in general, you could understand that group saying, okay, I think it's somewhere between the two pink dots. This group says, I think it's between these two pink dots, and so forth. So that green dot, which is where we started, if your group has 1 point to estimate what they think the parameter is, it's that green dot, and that is called a point estimate. And a point estimate is using a single statistic based on sample data to estimate a population parameter. Now, technically, this can be done with any statistic or parameter, but what do you think are the most common parameters that I'm going to be trying to estimate? Similar to last chapter. Okay, point estimate is the statistic. So if your group takes numbers, what kind of number do you think your group's going to have? Like what was your dot? Like your dot yesterday was a what? Monday was a what? Okay, so what was that as a symbol? X bar. Because we're dealing with means. What else could it be if we're not dealing with means? What? Last chapter was the other thing we dealt with. It's like this. It's a statistic. p-hat. So most of the time, we're going to be using X bar to estimate mu and p-hat to estimate p. But technically, we could do it with like S estimating sigma and stuff like that. And I'm just going to write one definition on each slide because I'm hoping that if I write bigger like that, then my pen will keep working. Instead of trying to write smaller. All right, so margin of error. Is pretty much exactly what it sounds like. It's technically, it shows how accurate we believe our estimate is, kind of. What do you think is talking about the margin of error? Colors. What? Whatever this is. The line one. So that is how far I think I might be wrong. I don't know which direction, but it's kind of how much it could be. So that's our margin of error. It's not like a definition, but it kind of shows how accurate we believe our estimate is. Now, yesterday, Monday, I think yesterday, when we had our dots, the first thing we came up was this one, which is our X bar. How did I figure out what that horizontal length was? It was the standard deviation. What was the difference in this one with the 68% versus our 95%? So it's how many standard deviations? This was only one standard deviation away. 95 ended up being 2 standard deviations away. So we haven't really talked about the equation yet, but I'm going to write an example that might not make sense yet, and that's fine, because I want you to have something to look back at. Where does the sigma over square root n come from? So that's finding the standard deviation using, like, the standard deviation of the sampling distribution using the population standard deviation and sample size. So that's what we were calling standard deviation. This is kind of a long shot. What is the definition of z-score? It's the number of something. What is this? Like, I know I'm writing 0 because that's what z is. But if I didn't write 0 there, this is my what of that distribution. Me. All right, so if I write 1, that's my z-score of 1. So that is how far I am what? So z equals number of, it's the number of what from the mean? So that's why there's a z here, because that was telling us how many standard deviations we were away. In the first problem, we were 1 away. In the second problem, we were 2 away. We haven't talked about it like that before, but making that connection from where we were to where we are. So that's just that length to the left and the length to the right is kind of the way we think about it. Number standard deviations from the mean. I didn't leave my free visual on that way. All right, so the next one is confidence level. And I will tell you now from the beginning, you're going to have an interpret for confidence level. You're going to have an interpret for confidence interval. So we have 2 separate things, a confidence level and a confidence interval. So confidence level is the success rate of the method used to construct the interval. So of the 2 problems we did, what were our 2 confidence levels? 68% and 95%. If we drew all of them out, the 68% should have actually captured the true parameter about 68% of the time. The 95% should have caught the true parameter about 95% of the time, but again, you'll never actually know if you did or didn't. And so as my, just kind of refresh, what happened to the width as my confidence level increased? They get wider or shorter? Wider. So as your confidence level increases, your width increases. So this is our interpret sentence. So this is that idea that we make all those, if we make a whole bunch of these, if I make a whole bunch of those, how many of them, I want to see the ones that do what? That actually capture the what? What are we estimating? In general, we're estimating a what? Parameter. So I want to see what percent of those actually capture the parameter. So that's pretty much exactly what the interpret sentence is. If I made all of them, that's how many would capture it. So this is blank percent of which samples? This is like just like chapter 7. Which samples? All possible ones. So my confidence level percent will capture that many percent of all possible samples of that size of whatever we're dealing with. Or that percent of all samples will result in an interval that captures what are we trying to capture in general? So we just said the parameter. So right now I'm writing mu, but that could be p. So you might want to write mu/p, which is the true whatever in context. So interpreting confidence level is if I made every single possible sample there were of that size, and I made an interval for each one of them, that many percent of those would actually contain the true thing we're trying to estimate. So like that's the whole idea of Monday. Questions on that, because that's like literally the whole interpretation of Monday. All right, so coming back to here, green dot is my what vocab? Point estimate. Blue line is my margin of error. So the only thing I haven't talked about is the pink dot chat. And that gives us our confidence interval. So it's used to estimate the thing we're actually trying to capture. And so you have a lower value and upper value. And I'm saying formula, but I'm writing a very, very generic formula in words. Alright, so you just told me green dot is point estimate, blue line is margin of error. So without numbers, how do I know where this goes? Like using those terms, how do I know where to put this? I start at my, and then do what with it? What is this called? Margin of error. If I want to go that way, I do what? If I want to go that way, I do what? Subtract. If I want to go that way, I. So that's the generic equation we're writing to start with. It is your point estimate plus or minus margin of error. And I'm going to rewrite that as something else that you shouldn't know yet, but I want to write it as we're doing this. So this can also be written as your point estimate plus or minus your critical value times standard deviation of the statistic. I'll put X bar slash P hat. All right, so I've never said the word critical value to you before. What do you think your critical value is? And I should have people who can answer that question now, and I've never even mentioned that word before because of what we wrote down today. All of this is my margin. Anything past the plus minus is margin of error. So this is margin of error. What is margin of error? My z-score times my standard deviation. So my standard deviation goes here. So what could my critical value be? Your z-score. So there's z and t are going to be critical values. We have talked about see it. I'm going to, underneath this, do my interpret for this, but I don't want to write on the bottom. So this is my interpret sentence for make your other one where it says interpret sentence. I would at least put an arrow to confidence level so you know which one is for. And this one either do the same thing or write confidence interval. Just do an arrow at the confidence interval, mine's on the same slide. Alright, so this one is we are number percent confident that mu or p, which is the true, what is this one? This is the true what? The top one. This is your true mean, this is your true portion. So it depends on which one we use. And you need in context. Falls between number and number. Now, if it's proportion, is it gonna have units? No, or 50%, but it's easier to write that they're units because means incorporated there too. So again, it's that idea of pitch black room, I toss a hula hoop. It either landed where it's supposed to or it's not. But theoretically, the idea of this is if I go and toss 100 hula hoops in this room, 95 of them would capture the thing it was supposed to. Or 68% would capture the thing it's supposed to. Like there's a dot on the floor. I don't know where that dot is. I don't know where anything is. It's pitch black. I'm just tossing hula hoops. If I did that over and over, that many percent of them would actually capture what it's supposed to. So it's not that that one interval is 95% correct. That one interval either caught it or it didn't. We just never know. Questions with that? Because that does become a little bit confusing to some people. All right, finding the critical value. All right, so I've got a curve, approximately normal, and I want to find a 68, or I want to deal with a 68% confidence interval. Well, I've got a lower and upper. Where do you think that lower, or where is the lower and upper versus the mean in relation to each other? So, like, is it going to be here and here? It's going to be what? It's going to be split for the same distance from the mean. Hello? Okay, thank you. Bye, Cassidy. They said you have early dismissal. Alright, so it's 68%. It's split equally. So that means whatever distance I am this way is the same distance I am this way. So it's the same distance apart. So from here to here is 68%. And we've got to figure out what this z-score is right here and what this z-score is right here. Our green sheet only shows us the area where? To the left. So I want to find area to the left. So like, let's say theoretically, I want to find this area right here. Or I've got to know what that area is to find my z-score that goes with it. Mathematically, if 68% is shaded, how do I figure out what is not shaded? Complement. So 100 minus that, or 1 minus 0.68. So I'm doing 1 minus my confidence level to get these together. But if I only want one of them, I do what with it? Divide by 2. So this little area right here, what area is it? It's 1 minus my confidence level divided by 2. So 100 minus 68% leaves me with what percent? 32 was 32 divided by 2. So in this scenario, this one is 16%. So that's an area of 0.0 or 0.1600. How do I find the z-score that goes with point? Go ahead and get your green sheets out if you haven't yet. How do I find the z-score that goes with 0.1600? Where do I look for 0.1600? In the middle or the outside? Middle. This is the area, so I want to look for it. Your z-table looks something like that. I want to look for it in like this part. And then once I find the closest thing to 0.1600, that's when I follow it out. And what is your closest z-score to 0.1600? Which is what, like, which follows out what z-score? It's easy for me to talk through if I got it in front of me. So so the closest, we've got 1611, is that my closest one? So it just said. And what, actually, yeah, yes, that one's closer. Barely. What is that z-score? What's that really close to? -1. Why should that make sense? 68% is 1 standard deviation away, which is a z-score of 1. So when we say 68% is 1, that's a very, very slight estimate. Like it's the difference of 0.0011 and 0.0013. So that's why 1 is an estimate. So do you see where this came from? So I can apply that to anything. So if this is -0.99, technically this area right here is 68% plus 16%, and I can look that up again. But why should I not do that? Because we don't know about that and that. So if this is -0.99, this is. So what is my critical value for 80%? So y'all should be able to do that. What's the first thing I do? I can draw it. Split equally, one on the left, one on the right. This is 80%. How do I figure out how much is just in that tail? One or 100 minus this, and that gives me what? So 80% is between, how much is not between? 20%. What do I want to do with that 20%? Divided by 2, so this is 10%. I'm looking up 0.1000. And that gets you a z-value of what? Which makes this a 1.28. So we would say our critical value z is plus or minus 1.28.
Does Z mean critical value?
Z is a critical value, yes.